Alrighty then.
Let's talk about thermal heat loss. Here's a screenshot of my Tapo app showing the two heaters and the temperature sensor. Here's a 24-hour mapping of the temperature in the cottage. Alrighty then, let's get to the nuts and bolts of cottage thermal resistance and heat loss. As you can see in the little drawing above, there's the cottage, the porch, the crawl space. There's the temperature in each of those places. There's the thermal resistance between the cottage and the porch, the thermal resistance between the cottage and the crawl space, the thermal resistance between the cottage and the outdoor air, the thermal resistance between the crawl space and the outside air. And then in the cottage, there's different thermal resistance for the 2x4 insulated walls, but also for the single pane glass. It's a bit of a mess. Anyway, I'm just going to do a rough approximation and say that the thermal resistance is 5. That's a bit of a stretch. It might be a little bit less than that, but let's use 5. So there is a formula, the transmission heat loss, and that's equal to U times A times delta T, where U is the thermal transmittance, which is 1 over the thermal resistance, area in square feet, and delta temperature, which is obviously the delta between the inside and outside temperature. Now, here's an example, and this is based on the screenshot I showed earlier. But in that example, you can see we had an inside temperature of 35 and an outside temperature of 0.4. That's minus 18 Celsius. Very cold. The area is 625 square feet, and we're just going to use a U of 1 over R, 1 over 5 of 0.2. Yeah, so now we can calculate the thermal heat loss, transmission heat loss, and that ends up being 4,325 BTUs per hour. This is a significant number to understand. It just means that you would need 1 heater to start to heat the cottage. So that's really good to know. In this particular example, we had 2 heaters, and we were able to bring up the temperature in the cottage by 5 degrees in 4 hours. Obviously, if we added the 3rd heater, we could expand on that. And it gives you a good idea because we know that we could even withstand more of a delta T loss. So if it was even colder, the difference between the outside and the inside, we could still maintain the ability to heat the cottage. Anyway, that's it for now. See ya!
Thanks for watching. See ya.